Yes, welcome. As usual, I will delay for a little bit at the start just because of some of the adverts that I know will be thrust upon the audience without my permission. I don't get to see any of the money from those adverts, so don't click on them. That's all I can say. Anyway, I have decided this episode we're going to just quickly start with how we finished off last time. Because we were looking at the tile space transformations and removing some artifacts from them, and we've got an update on that. And then I thought, well, we've not done space thing for a few weeks now. The reason being, it's a little bit needed a break from it. Been doing it now for what are we on now? What are we on? 28 episodes. So I think we've done like 26 episodes of space thing, spaced out almost every week. Interesting. Let's see if anybody is here. I know Dandestein and Magetsub are pottering about in the background. Don't know about anybody else, but hey, we'll carry on. So the last episode ended on a bit of a cliffhanger because we had a problem with tile rendering. Null Alternative, hello, yes. Berg, hello. Gruffler, hello. And and Meg is telling everybody to meg off. Brachistochrony, hello. Christian Seiler, hello. Yeah, there we go. This is going to be a cooking show. No, everybody meg off. For those that aren't in on the joke, Megarev's like one of the most friendly people you'll ever meet on the Discord server. Always welcoming, telling everybody how happy he is to see them. He helps everybody out. So we've got the phrase now that, go and get megged or meg off. Or go meg yourself or something. And it means, have a nice day. Have a good time. Thunderburn, hello. Unnamed Tino, hello. OHK, hello. Desp is here as well. Somebody getting megged. Remind me of Gorbit when he wanted to. Yeah. Right, so we had the artifacts last time. Now, we're not going to do the whole episode about artifacts because I think I have solved this problem. And it did take a little bit of time offline as well. And I want to throw some thanks towards Dandestein, as usual. In the OLC CodeZone chat, Dandestein carried on doing a little bit of investigative work on his own. And we took sort of different approaches to trying to get to the same solution, but one of the things that really helped was Dandestein suggested, why don't I also render the wireframes and see actually what's going on, and that did start to reveal a bit more information about solving the problem. But I'm pleased to say that if you are now tiling with decals and you're using the transformed view and draw partial decal, which you probably would be if you're using an atlas, then I think the problem is solved. And I will demonstrate by running the application, then we'll just quickly talk about what we think was going on. So the application was just as it was before. I'm just going to draw a 20 by 20 grid of some tile from a tile sheet. So there is the tile maps, 20 by 20 tiles, and now I can zoom to arbitrary zoom levels, and you'll see there is no artifacts and there are no sampling problems. The other thing that we didn't really talk about in the last episode is that the window size also would influence where the artifacts appeared. So that has also been remedied. Now that's quite an important one because that would give different behavior on different people's machines. So I'm pleased to say that that's gone too. I'm really pleased with this. Sorry, a little bit of my vegetable stew just making its reappearance there. I'm quite pleased because it has been a frustrating point for many users of the Pixel game engine, including myself, that when we've been trying to just do simple tile-based environments, and let's face it, if you're using the Pixel game engine, you're 99% of the time going to be operating with tiles in some way, shape or form. And it's been very frustrating that doing it with decals has led to rather unsatisfactory results. So there was a sequence of fixes that have gone into sorting this out. You also notice that the sampling for the tiles is actually kind of even too. You still got to make an awkward decision about whether a pixel gets allocated to one screen pixel or two. Nothing we can do about that, but it does actually all look quite even. So I'm quite pleased with that. Captain Gaspacho, hello. Yes. Saucy63, hello. Channel, hello. Apostolisk, hello, yes. Zadruga, hi. Is OLC framework based on DirectX? No, it's based on OpenGL, but there is a DirectX backend that somebody was working on. I know a few people have worked on a few of them. Hello, Jared, everybody in the chat. Speedy is ready for another episode. Excellent. Welcome, Speedy. Always good to see Speedy here. Is the problem similar to lerp function implementation? In a way, kind of, yes. Did I? Lots of questions here. Did I come to a conclusion about my smartwatch selection? Yeah, I'm going to hold off because it looks like the whole next generation of smartwatches is literally coming out in 2 months. So either the prices will drop considerably of this generation, or I may as well wait and get something that's new. So I'm just going to hold off just a little bit. I'm not going to sort of repeat what all the problems were, but yes, in a nutshell, I think we've solved the tile rendering problem, and we can test that even more extremely because I created a nice little demo. I put a video of this on the Discord, so I'm just going to cancel that one out and bring this one in, I think, yeah. And we'll rerun that. So this is just a repeat of the video that I showed before. So we've got sort of it's procedurally generating infinite number of tiles. Of course, the Twitch compression is going to absolutely love this. We can have many tiles. So this is we're going into negative space. This is the void over there. So we'll just keep going this way. And as you can see, the pixel game it's dropped down to fairly miserable performance at this rate. But I mean, it's drawing many tiles at this point. So you get to something sensible. You want to get to your 60 frames per second mark. That's still quite a lot of tiles for it to be drawing accurately. And even if you're doing something at this kind of resolution, we're now back up in the several hundreds of frames per second. So decal tiling without artifacts has been a big deal, a big thing to actually improve. I think we'll see a lot of people using this now. I've not yet uploaded the Pixel Game Engine fixes or the next version of it and the transform view, but I will do. I've already, for those that have been dead keen, I've actually put the code in the Discord channel too. Yeah, Danderstein's right there. It is a similar problem. There's actually like a few problems that some of them were actually my fault, and who would have thought it? For those that didn't realise, there was actually two problems we were trying to solve. The first was why were the tiles appearing with gaps in between them, and the second was one that we never really got around to demonstrating. Because these ones look like they've got a gap in between them. It's actually because the tile isn't the full tile. It's a little bit deceptive, that one. So the second was actually an OpenGL sampling problem. And I'll quickly look at the solution for both. If we go to the Pixel Game Engine header file, here is the draw partial decal routine. Now, the code doesn't look that different, but one of the changes that I made was to keep everything in the floating point domain right up until the last minute. So that was a bit of a goof on my part, thinking that the compiler might actually help me out a little bit. The reason you might, because your screen and everything is in integer space, and of course your pixels are all integers, so it makes sense to start thinking about things in terms of integers. The problem is until you start transforming them arbitrarily. It wasn't casting to integer, but what happens is I can pull in the original code. Actually, where's the original line of code? Let me pull this in. So the main change here was this line and these lines. So the maths has changed a little bit here. I'm just going to bring up the old maths, which looks a bit like this. So you can imagine this line sort of sat in here with its y counterpart. And the problem is, if you had an error at this point, you've immediately introduced an error into the second stage. So this calculation here, this posx multiplied by inverse of screen, that's never going to be perfect. That's in floating point, that's never going to be quite right. So you're going to get reasonably right plus or minus some error. And then you start off on that plus or minus some error and then introduce a little bit more error to it. And it turns out you're better off trying to let the compiler and let the processor do what it's supposed to do. And this way we're trying to avoid a little bit more error. So instead of bringing the error in from the first time round, I'm actually sort of letting it sort itself out. So I'm recalculating that position up here. So the changing around the floating point stuff has kind of helped a bit. It makes the error a little bit more predictable and a little bit more manageable. So that was sort of the main change. And that one was the one that got rid of the gaps in between things. The second problem wasn't necessarily apparent straight away. Sorry, that solved the rendering problem of big gaps and things being quite strange. The second problem was one that we did bring up last time, which was this quantization issue. And I thought that the boundaries of the pixels need to be quantized to the same pixels on the screen. Careful you don't kill your 3090 with those frames. Yeah, nothing like that. I have a 980 Ti. You'll all be laughing at that now. We'll be coming back to Space Thing in a minute. Hey, Alex. Hey, and Dragon Eye. Welcome. So the second big change was that everything happens in normalized space in the pixel game. Once you get to this point, we've actually normalized the coordinates. So we're no longer in pixel space. We're in regular GPU screen space. It's normalized. But you've got to try and guarantee that you're going to line up with a pixel on the monitor. Now, this is to sort of fix one of the OpenGL glitches, which is a bit strange. So the only way you can do that is to sort of scale by how many pixels you've got on the screen. Now, the Pixel Game Engine has its own game engine screen, which we all know and love, right? It's screen width, screen height, you specify it at the start. But actually, how much is it taking up on the physical monitor? How many pixels are allocated to that at any one time? And that's calculatable. So internally, the Pixel Game Engine has access to that through a variable called view size. And so again, I take the floating point equivalent of this as a window, and I use this as a scaling factor, where I scale up the normalized coordinates back into pixel space. Now, this is genuine sort of windows on the monitor space now. And then for the top left coordinate, I floor them, and for the bottom right coordinate, I take the ceiling. Now, you'll notice a quick minus in there. I'll come back to that in a minute. And the reason for doing this is to always make sure that we're biasing the edges of the polygons in the same directions. So it's not that the polygons end up in the wrong place, but they know that they're allowed to share a pixel. And that's a big difference, because that's part of the problem. Previously, if you rendered from 0 to 1, it would actually sort of render from 0 to 0.999999999. So leave a little tiny gap in there. You want it to just sort of clock over to that 1. Sometimes, right? But not all the time. And that's why we've got this sort of rounding going on. Now, the minus in here is interesting because we've actually already gone into the screen space here by inverting. So if you recall, everything we do is relative to the top left. That's computing convention. But when you start actually rendering things with computing convention, it's actually all upside down. So that's what this negative sign is doing. But we need to account for that when we're doing the rounding offset now. So that's why there's a minus here. The third fix, we're almost done. The third fix was now the texture sampling. Now, this is actually a real problem because if you have a texture atlas and it's sampling along the edge between two tiles, in certain situations, and it's not always repeatable for OpenGL, it just gets it wrong. It samples from texels that it shouldn't be looking at. Now, I can understand that happening in linear filtering modes. I can understand that happening in anisotropic filtering modes. I can understand it's doing clever things there to try and calculate the sample. But the Pixel Game Engine by default uses nearest neighbor. There's absolutely no reason it should get it wrong, but it does. So I fixed that by just adding in a bodge factor. Which was similar to the bodge factor that was suggested last time, so except for slightly different reasons. This just brings the texture inside the decal in ever so slightly. It's very, very small. It's there purely to bias the maths. It has no functional visual sort of effect on the screen until your decal gets very large. So if you've got a texture atlas which is 10,000 by 10,000 pixels, that's unusual, not unheard of, but it would be unusual. Then you might start seeing some little bias artifacts appearing. The textures might look a bit stretched across the surface of the decal. In that situation, though, there's nothing stopping you coming in and playing around with this number. So these four fixes. The first one we actually did fix was in the transform view itself, the world to screen function. had a erroneous flaw in there which had been sort of propagated through from various tests of this. The second one was to sort of reorganize the floating point and the integer calculations just to make sure we're not inadvertently truncating any information we want, but also to make sure that the error isn't sort of magnified, as it were, as we're doing more and more operations. It keeps the error consistent. The third thing was to then quantize to the actual screen itself, so nothing to do with the game engine, but the actual physical monitor. Finally, just biasing the textures slightly to make it work. And the end result, I think, it works quite well. I'm pleased with it, and I believe quite a few people will like to use this now. The tile set, by the way, is this open source tile set. Well, not open source, it's Creative Commons license, I think, called Nature. It's a popular one. Everybody on the server has got this tile set. I've not drawn it. Right, what have we got? All sound like Atari computers to me. Yeah. Oh, the graphics cards. Hey, I want to make a program, but one of the things I need to do is map nodes to the different parts of the face. I saw your videos on integral images and 8 bits of image processing. I was wondering what functions would I need to use the implement half feature and Viola-Jones algorithm in a real-time application. Viola-Jones is really fascinating as an algorithm. I first encountered Viola-Jones when it was implemented on a mouse. Somebody had used the camera and the co-processor of a regular optical mouse to implement face detection. It's not face identification, face detection. And if you've excuse me, if you've ever sort of done face detection, it's a miracle that it kind of all works. But it turns out your face is actually very, very simple to identify in real time. I'm just trying to think. I actually have a demo in the Pixel game engine of Viola-Jones doing its thing, but I don't think I'll be able to get it up and running today. And one of the ways it works, it uses this thing called half features, which are basically black and white shapes. Now, I did a video called Integral Images, and it was actually Integral Images it was Viola-Jones's implementation which actually introduced me to Integral Images in the first place. So if you wanted to do kernel convolutions over large scale, load large parts of the image, typically you would have to do element by element. But if you remember from that video, you can do integral images. You can work out the sum of a region very, very quickly indeed. And that's exactly how these implementations work. What Gaspacho here is asking is how do you actually construct the feature set? The feature set is not. It's not easy to construct. It's not just something you would throw together. The way I tried to do it and failed to do it successfully, I should add, was to take a regular sort of MLP kind of network and use you've only got so many different shapes, right? So the plan is to look at the different spatial scales. So your first top level transform is all white at the top and all black at the bottom. Then you have the corresponding one to that, which is all black on one side and all white down the other. And you can look at this various transformations, and you sort of spatially scale those and build them up into layers. So I think you ended up needing something like 8 layers or so before you started getting sensible results out of it. And it turns out that to recognize a face, all you need to do is recognize a dark T on a white background, and that's basically a face. And the nice thing is you can work it out sort of scale invariant too, and that's how these cameras from even like the late 90s digital cameras had this ability to sort of put a circle around a face and things. It's all interesting stuff. So yeah, dig into Viola-Jones. It's good fun. It's not perfect by any means. I think it is actually technically a racist algorithm. It does struggle under certain circumstances. But there is it's not open source, but Viola and Jones did release a C library which exposed the feature set and made it very easy to use. Let me just have a dig around for that just for a second. Let me just pull that up there. I'm not promising anything here, but it'd be good to see if I can just find that algorithm. Where am I looking? I'm looking in my old Pixel Game Engine development library. Old Pixel Game Engine. So I wanted to do I was looking into doing it for a follow-up to the image processing video. I thought, oh, it's interesting stuff, Viola-Jones. But then there's quite a lot of stuff to do to make it into an interesting video. Where is it? Where is it? There we go. So what I'm looking for is not my Pixel Game Engine code. It's the library that Viola-Jones provide. Because I'm guessing the source code should just be dumped somewhere in my source code folder. You think I'm organized, you've got another thing coming. I just have one big folder with all of my files in it. Don't recommend it. There we go. Right, that was it. That's what I'm looking for. fdlib. So let's just stop that for a second, and we'll just pull fdlib in. It's very, very simple. This is it. This is fdlib.h. So this is Viola and Jones's code. And it's got these three simple functions. There's a DLL file and a lib file as well, of course, which is just simply detect faces. You pass in an image, you give it the size, and you give it some threshold, because it really only works on sort of black and white images. And you can get how many faces did it detect for that frame, and you can get the positions and size for that particular face. But they also provide a DAT file, and the DAT file, I think it's all binary encrypted, so you can't sensibly understand it. But that DAT file contains a ready-trained HAR decomposition network in order to extract faces from images. So there we go, a little bit of a tangent there, but yeah, somebody mentioned Viola-Jones. I have a little bit of experience of Viola-Jones. And it's definitely worth looking into if you're doing image face detection. The idea is it's just to give you that sort of broad face search. So it'll say faces, and then you can go on to do something else. So once you've got that sort of x and y coordinates of where a face might be, what the probability of a face might be, and approximate size, you can then zone in with your detection algorithm to go and do some identification, or to do something like skin tone matching, or what other sort of subsequent downstream algorithms you might want to implement on that. So that's how I ended up implementing Viola-Jones. I used Viola-Jones's own code and just used it. It was far much more fun just working with the end application. It's a shame I've not got the code for that to make it up and running. I have to get the other webcam up and running and all sorts of things, and I'm not going to sort of dismantle all of the stream now. How long would it take to train the algorithm from scratch? Oh, only a few minutes. It doesn't take too long. Quick question. What's your opinion on design patterns in C++ versions greater than 11? Do you find Goff design patterns useful? Well, the fact that I don't even know what Goff means probably tells you no, I don't. Somebody's going to have to illuminate me on what Goff. I mean, I was a goth. TH. Gang of 4. Yeah, see, obviously not. I don't find any of these things useful at all. There we go. So, not for me. I'm not very much into the computer science of language at all. I know some people find that quite strange. I really couldn't care less. The fact that I'm using C++, it's because it's what I know. If I had the option to use something that was simpler and easier, but just as performant, I would use that. I have no particular allegiance to any language. Goth music used to be my favourite. Yeah, I like a bit of goth music too. Right, so with that, let's get rid of fdlib. We've now fixed transformed view, and big thanks to Danderstein for pointing me in the right direction there. There's a little bit more analysis and some sort of experimental videos in the CodeZone chat on the Discord server if you're interested in digging into what's going on there. But I'm happy to say that it's fixed. And then I thought, well, should I update all of my other decal routines? And I decided against it. Well, I'm probably going to update this one, but they're all slightly different. And I don't think, unless somebody ends up deciding for themselves, what I need to do is draw all of my decals as individual tiles in my own transform space, which is what I think TGD is doing. TGD has used this since and has a complaint saying I'm still getting artifacts, and I think that's what's going on there, TGD, when you watch the video of this. And I know he will, because he enjoys these things. So I think the other decal routines don't necessarily need to have this implementation, but the one that I will update rather strangely, not many people know this one exists, is fill rect decal. So you can still, this has got remnants of when we were experimenting in the last video. Fill rect decal is a quick way of drawing a rectangle on the screen, and you've also got its counterpart, gradient fill rect decal. These are great for lighting and large sort of swathes of interesting texture across the screen, because decals can render with full transparency quite easily. And you can also, if you didn't know, I have additive modes and different lighting modes that you can render decals in. You don't just always have to blend them. You can, particularly additive is very nice for doing interesting lighting stuff. So, there we go. Tiling sorted. I'm happy to draw a line under tiling. One of the things to always test, of course, when you've made a change to one of your fundamental parts of your libraries is to actually go and run them somewhere else. So I'm just going to... Hang on, what have I not saved in this file just before I move on? Oh, because I stuck a line in code. Right, okay, that's fine. I can save that. So I'm going to pull up Space Thing again, which is opened on this window. There we go. Because it has been a little bit of time since we last really looked at Space Thing, and I think one of the reasons I can't quite remember where we got up to. I know we started implementing the GUI because we wanted to start looking at the properties of things being developed, and I remember that we added wireframe because again it was something else. So we were sort of adding in tools but not really using them. But let's have a look. Where did we get up to with Space Thing? Whilst I have a slurp of water. Slice, hello. Gondar, hello. We had a box flying. I remember we had some gears. Oh yeah, we had a box sort of appearing from the sun flying towards. Yeah, yeah. We'll have a look because I really generally can't remember. But that's what I thought today's episode we could look at. We could start sort of analysing the code, become a little bit more familiar with where it's up to, basically refreshing my mind, and then deciding on perhaps a few little things to implement over the next few episodes. What features are we interested in seeing? Because at the moment it's still not a game by any means. It's really just a collection of rendering techniques and data structures and things that we're interested in, so that we can get rid of the GUI. So I did sort out the events in the GUI. We've just not tied everything to events yet. So we did have that one changing the speed of the simulation, didn't we? Let's just get you out the way for the time being, because then we added selection, and there was a bug with the selection state machine. So when you go to nothing and then you select something, it adds it twice to this this list. And there's a little bug with the list which needs ironing out. And it's the little bugs that I don't like doing on the streams because they're not necessarily that interesting. You can see the scroll bar for some reason lags by a couple of entries on the contents of the list. So that's fixable, I'm sure. And there was some little cosmetic changes to make to the list as well. It's kind of coming back to me now. We had the menu appear. The menu didn't do anything yet. But we had a nice looking GUI. And we talked a lot about GUI and skinning. Okay, I remember. It's all slowly coming back. And we had the ability that you could select a planet. And if I remember, yeah, we can press the S key to bring up a space station. There we go. And when we were in space station mode, we can press the S key again. That was it. To place additional modules. What was the keys to change the modules? Up and down. There we go. So modules had the ability to only be placed in the correct locations, which was quite nice. We didn't have the ability to do anything with the modules yet, but they behave as a space station floating through the simulation. In fact, let's just slow down the speed of the simulation just temporarily. There we go. And I remember that we could add additional space stations. And we could add them to different planets and different moons. So if it's got a big M there, it was a moon. In fact, let's just have a quick look at a planet. Because one of the things we did introduce was jitter again for high zoomed in things. And that seems to have disappeared now we've fixed the transform view properly. So I'm pleased with that. Have a look at this planet. Yeah, let's speed the simulation up again. Good, it doesn't jitter, but we've got the light slowly moving across the planet. The planet's moving very slowly through space, and it follows the light. Right, good. Okay. And then we added one final feature just to sort of start playing with this. We had the ability that if we selected a satellite, and for some reason we pressed the R key and selected another satellite, I could link them up together with a route. Hey, there it is. There's our wireframe gear alien. And the point was to just see what the routes look like when they're being visualized. And every time we created a route, we cast another one of these wireframe spaceships for some reason. There we go. So it got a little bit silly, but the idea of the wireframe spaceship was, one, to demonstrate the wireframe PegX, which I think is interesting. This does have some jitter, and I think this jitter is because we update the wireframe before we update the location of the space station, and then we draw the two. So they're always sort of playing catch up with each other, these things. Yeah, so the wireframes get a bit jittery for some reason. We'll maybe have to iron that one out. But the objective was actually what's going on with the gears. The fact that they're there is mostly irrelevant. It was more about the fact that they can automatically navigate to where they needed to be. Yes. So you see, yeah, it's pretty bad actually, the jitter. So this is always playing catch up, and I think that's just the sequencing of events going on in the game. Well, the nice thing about the wireframes is these are rendered by the GPU, so they cost very little. And I wanted to include wireframe as a debugging overlay for stuff, right? Because we can draw these lines, and we might want to draw ships and that sort of thing. It's an easy way of doing graphics without needing to do graphics. So yes, so more intelligent flight patterns through steering behaviors. I think that's the next thing I would be quite interested in working on. Not necessarily exactly that, but giving the spacecraft a primitive AI. So I quite like the idea of the spacecraft being a state machine fundamentally, which can enter a set of known states. Now I think one of those will be I am traveling to a destination. The other will be I'm in a holding pattern because I want to make sure that you can't just always dock at a space station. There has to be space for you to be there. Then you've got landing, and you've got takeoff, and you've got trading. So there's actually quite a bunch of states that the ships will exist in. They may also exist in a few others. So things like, we've not even discussed things like combat and that kind of thing yet. Is that something we're going to go down? I don't know. But I do like the idea, and the more I think about it, the more I kind of think, well, we started off that way and then moved away from it. I like the idea of the user being able to control at least one ship, because I feel that that's how the user should go and explore the galaxy. And that's where I think there'll be lots of like useful stuff and funny things, and I want to incentivize the player actually just sort of going out there and grinding a little bit and just exploring to see what's there. But I want to make it rewarding at the same time. So I quite like the idea of giving the player a ship of their own that they can go and control with. It's a bit like Anno in that regard, but at the same time, if you've got this sort of space technology, you can probably immediately image your current solar system quite accurately. So in terms of the LORE law, it probably doesn't work out very well, needing the user to pilot a ship. Yeah, Space Zelda, exactly. I just quite like the idea of it. It forces the user to go and visit a planet before you know what's there. So I don't want sort of you start the system and you immediately can just look at a list of all of the resources on a particular planet and just cheat your way through it. Basically like Dragon Eye and Elite. I don't want to do that. I'd rather the user has to go and visit somewhere new to explore it and see whether it's worth occupying or not. But then I don't know what's going to happen if we do want sort of alien invading forces and if we do want some sort of team thing later on. But I do know that whatever we come up with, the engine has to be capable of running with that. There's an in-joke, for those that don't fully understand, in-joke, basically Dragon Eye, moderator on the Discord server. Moderator, good friend, but terrible cheat at Elite Dangerous. Oh, cheats so badly. Oh yeah, we had all the asteroids and things up here. In fact, we had the whole solar system was procedurally generated now. And what is this green line? Why is there a green diagonal line? I can't remember what that was doing. Was that testing something to do with the wireframe? So let's go and refamiliarize ourselves with the code a little bit and understand what's going on with this line. So let's pop back into main now, I guess, and I'll just zoom out a little bit for... Oh, that's one of the things I did add. Because this code is almost always the same, I added it into the transform view as a convenience thing. So let's just have a quick look at that, because there are people that do use the transform view, and they might want to see how this works. So now there should be handle, pan, and zoom. And it's got a whole bunch of default arguments. So you could just leave it like that, and it will default to middle mouse button doing both panning and zooming. Convenient stuff. But the arguments are, you can specify which mouse button you want to do the thing. So right now I use middle mouse button. That's the first argument, so that would be 2. You can specify the zoom rate. So this is the, if you subtract 1 from this and subtract and add to that to make it to 1, you can see my zoom rate here is 0.1, so that's what we specify in the second argument. What was the third one? And then the last 2 arguments are just true and false for both the pan and zoom. So you might not always want zooming in your application, you might not always want panning, you might just want zooming. So the handle, pan, and zoom function just tidies up this code. So I could just take that there and let's... and this got me thinking as well. When you start thinking, oh, well, I'm handling pan and zoom, one of the things I'm fed up of writing over and over and over again is a camera system. I'm tired of doing it because it's always a little bit different each time, but on the whole, it's kind of the same. So I think I'm going to invest some time in creating a extension that represents a camera, and the best place to put that is in the transform view extension. So rather than a separate extension for cameras, it's actually going to be sort of integral. So we might have something like a camera view, camera transform view override for the base class. And we can add all sorts of different camera modes there, sort of interpolated cameras, instant cameras, lazy following cameras, all the usual stuff you would see in different game applications. I just feel that I'm fed up of writing this same code, and if it's a nice transform view with a built-in camera, that's a very game engine thing. So straight away you can just say, well, I want to look at this part in the world. The transform view is capable of telling you what information you can see at any given time, and a tile transform view, even better, it'll tell you precisely which tiles you can see at any one time, and then you can draw your game world. So I think we'll definitely be adding cameras into that. So that might be something that's coming up in a future episode. We want to handle cameras. You know what? I'm going to add this to the stuff to do list because some of this has changed. So let's... oh, we have to celebrate Apostolisk's awesomeness, apparently. Well, there you are, you see Apostolisk. Pretty awesome. So I want to add in, yes, camera to transform view. We'll keep a note of that. And there's a whole different variety of camera models to apply. It's not just moving to one location. You may as well have things that when you nudge your camera towards the edge of a screen, for example, does it move the camera along, and then it goes all slack and lazy in between? Does it smoothly interpolate? Can we lock the camera to a sub-rectangle of a bigger world? That's a tactic you often see in games, 2D side-scrollers, which they don't want you to have this sort of free roaming camera ability. They lock you into a corridor whilst you're scrolling. Things like Castlevania spring to mind in that instance. So I think we'll have those sort of camera modes, and these are reasonably trivial to implement as well. So that's an important thing to add in. What have we got here that we've not done? Let's have a look. So intro title. So I don't think anybody actually wanted me to put an intro title on the videos, did we? GitHub roots. That was decided. Yes, we did. We did a dedicated Discord chat. So that one's done. In fact, if they're done, I'm going to mark them as done. So we did that. GitHub repo for this stuff. Yes, but not now is the answer to that. I want things to just get a little bit more stable. Intro title, I think collectively people have sort of gone, yeah, not too bothered about that. Silly noises and graphics for bugs and fails. This is sort of stream stuff. Maybe I kind of want to do that. And guest speakers, I also want to do that as well. I want to get people from the community chatting about their projects at some point. Space Dust. Well, we kind of sacrificed Space Dust for lots of other things because we moved away from it being sort of a real-time space simulation into more of an RTS game. Stars in the background, we've done that. Yep, done. Hacker spacecraft, we've not done that. Asteroid ring, we did asteroid ring, we've done that. Giant gas clouds, so they were the things in the background, all of the multiple layers. Stars to background as a layer, yes, that was to increase the rendering speed of things. Scaling of the world, yes, we did that. Celebrate Apocalypse Awesome, we've done that, so we never need to celebrate Apocalypse Awesomeness ever again. So we're not doing too bad, actually, on the things to do list. Good, good, good. Right, let's go and have a look at the main function because it's getting a bit busy, the main function. You can see we've got combinations of panning and zooming, mixing. There's all sorts of things going on in this main function now. And a lot of people are going to say, well, that's because you didn't break your stuff out into states and different classes. And they're kind of right, but I'm still not ready to go down that route yet. In our on-news update, what are we doing? So we start off by drawing a blank frame, and then we update the GUI. That's it. So GUI is completely all handled, and it's it's drawn as a sprite. Excuse me a second. I have to check the old pings periodically. Excellent. So right now, all the GUI stuff's drawn as a oh dear me, all the GUI stuff's drawn as a sprite. But I want to make it also drawable as decals, and my GUI framework should allow us to do that quite easily too. You don't really get a performance advantage as drawing things as decals in the GUI framework, and maybe that's a discussion for a future episode. Does the GUI have any events? We talked about eventing stuff, didn't we? Yes, so we've now got the ability to reset the camera and set the scale. We've seen it do that, so we don't need to do any of this. This was the old way of handling events. That can go. Time. So we have the desimulation time. This was the time modifier, so we could change the speed of the simulation. That was working quite nicely. And then we went and updated our systems from our entity component system. Obviously, there's like a nice big hack number stuck in the middle of that thing there. We may need to look at this in more detail at some point. What is time in our universe and how fast should it go? To make things a bit... It's difficult, and I think we probably brought it up before, but you kind of want your planets to be... You want to know that they're moving. You want to see and feel that they're actually doing something in space. So we may as well just present a big static image, which is less fun, I think. My phone is enslaving me. It's different now because it could be saying something like, "Hang on, the baby has, I don't know, fallen down a manhole or something." So I have to check it. I can't not check it. Then we have the states. Now, one of the things that was a little bit untidy regarding the states is they actually have several state machines all with the same states, but they're doing different things. So this was what was displayed on the screen, and how did the user interact with the game state machine. So there's actually no real... well, the plan was no gaming stuff was going on in that state machine, but it ended up being very much things like creating routes. It's falling into that state machine. So I think that needs tidying up a little bit too. The space station edit mode. We saw we can place all the different space station modules. That was done in a whole episode dedicated to just how that works, and we created these fantastic utility functions that make that quite a trivial thing to do. The space stations don't do anything yet because we don't know what the game mode is just yet. So it's going to go on for a long time, this series. Then we use the state machine again for just positioning the cameras. And that's what, again, I kind of feel that cameras is probably where we're going to go soon with this. Because we do want different types of camera, and cameras always interact with the transform views that are going on in the background. So I think we can probably make a lot of this disappear by integrating cameras into the transform view. I think that might be really worthwhile doing. Then we had this this was a strange situation here. We have two transform views, basically one's transposed on top of the other. Transposed? That's not the right word. Not quite sure what the right word is. One is on top of the other, and they both receive the same set of events to have the same set of behaviors at the same time. I think that's untidy. There's probably a nicer way to math that one out rather than just duplicating the functionality. And there's our mysterious draw line. Well, we don't want to draw the line anymore. That's just drawing, for some reason, it's just drawing a big long line as a sprite on a layer. I can't remember. Was we talking about clipping or something? Was that what that was proving, that it was clipping without affecting the frame rate? Don't know. Then we looked at the wireframe PegX, and that was quite important because I think that's got a lot of utility. This is a PegX I've created at work, and I'm using it all the time. It's probably the most useful PegX I've ever created. It's really interesting. It got to the point where I've actually implemented a complete vectorized font for it as well. So I'm pretty pleased with how that's come together. Let's have a look. Oh, hang on, we've got some chats going on. Baby out in the streets crawling already. Yes, it's not far off. We're all very, very tired. Even though we're all brothers born of the same earth mother. Yeah, that's getting pretty hippie there. That's getting a bit too deep for me. Then we have the state machine again, and this is just the state machine for rendering. A random lol there for some reason. I can't remember half these things. And this is where we decided how we were compositing the scene. So there's literally nothing but graphics going on in here. But it does look a little bit chaotic. Well, there's repetition again. I don't mind repetition in a state machine. But as you can see, there's no comments, there's nothing. So I probably do need to have a good old solid refactor of a lot of this to make it work. Also, the descriptive text is now no longer good. But there was a couple of utilities that we added, wasn't there? Or at least one utility that we added. And I'm going to export this into Saladin's animated sprite PegX, I think. And it was this asset pool, so it was a complete header file, wasn't it? Because I quite like this as a way of making sure you've only got one asset loaded at a time. And that's exactly what we need to do with Saladin's animated sprite PegX. In fact, I did think for this episode, what we might do is look at Saladin's PegX and fix a particular problem I have with it. And I thought it might be useful to do that as a stream. And maybe I'll do that, save that one for a one-off stream when I don't feel like doing any space thing. But there's a fix there. I've been desperate to make it for ages, and I just need to do it. Standard forward the args. I'm fed up with the standard library. Anything else that's more standard library, I can't be bothered with. There's literally no point. Oh, okay. I'm just trying to think of all the other bits and pieces where we had things. Yeah, because we didn't have in components. I started mapping out the components. So that was something that we never talked about on stream. We started looking at all of the components we'd made for the entity component system and what the objects in the game were actually comprised of. And I wanted some sort of map of them so we could see, were we using the most sensible set of components, or could we reduce the components that we're interested in having? I think we can. So I think there's actually quite a bit of optimization to be done in this, and also some renaming of the components to make them a bit more sensible. Yeah, things like sphere, for example. Why has a ship got a sphere component? It's weird things like that that I don't quite like. And I also wanted to add in, and I haven't yet, but I've added it into this map, artificial component. So anything that's effectively man-made is going to have this artificial component added to it. And I kind of think that that's going to be necessary for some of the systems, so you can quickly identify ships versus just things going on in nature. So a little bit of a change there coming up. The actual systems, we didn't have anything yet. So we're going to loaders. These were the drawing routines in graphics, weren't they? Yeah, okay. I'm not going to change the graphics routines too much, but what I think I do need to start adding is some comments, certainly. But also, I've got lots of hard-coded things in whilst we've been experimenting and debugging. This isn't good, of course. Now, the plan was to try and offload some of this to Lua. And maybe that's where we start taking this. We start actually bringing the data in from an external file. Because I think once we've got the Lua integration sorted out, and we've got the camera stuff sorted out, I'm then going to be happier about sticking it all in a repo. Got to understand, as soon as I put this in a repo, some people are going to download it and start trying to hack it together. We'll see. Thorium Z subscribed. Oh, thank you very much. Tier 1 for 3 months. Oh, thank you very much, Thorium Z. I didn't get a ping or oh, it's because my speakers are switched off. Oh dear. But there's all sorts of background music and things been playing, and also can't tell. I've had my speakers off. Holy Seraphim on Alter. You missed the CodeZone. Well, we've only got 10 minutes of CodeZone left. In a nutshell, we've fixed our tile problems that we had last episode, and I'm just refreshing myself with the space thing code, because it's been a couple of weeks since I last looked at it in some detail. The space station stuff, other than constructing them, they don't do anything yet, and I think that's where we need to do a bit of game design as well. And there's all sorts of things to be working on. I'm pretty pleased that it's actually starting to come together to the point where we're looking to glue the files together and make it actually come together as a game. Yeah, I'm not thinking aloud all the time. Systems, there was nothing. Yeah, there wasn't very many systems that we had so far. So updating the orbital positions, something that popped up a few times as part of the discussions we were having on the server was there's a lot of repetition. There's a lot of just iterating through stuff in the entity component system, and I've not done any profiling, but I think we will get to a point where we need to start looking at, how many things are we actually iterating through? Is it doing it quickly? Are we benefiting from having the ECS if we've got to iterate through the same data 10, 20 times in an update loop? Is there something better we can do? Yeah, you see, the problem is Irish Brews is you've mentioned 2 languages there I've never heard of. And I've been around the block a little bit, so you end up in a situation where it's just using languages for the sake of using other languages. Lua isn't perfect; it's got problems, but at least there's support. There's actually people actively developing it. There's a live, living community of people and libraries that are written for it and all sorts of things. So it's always difficult because Magetsu mentions Angel Script. I know that's the particular scripting language that he likes, and same sort of thing. As the 10 people that are using Angel Script, Magetsu is one of them, and he's a proponent of it, which is completely fine. I'm not going to go back over that, Alter. It was not perhaps as interesting as you thought. It's a bit of a maths rounding problem that we needed to sort out. So I have nothing against different languages, but I'm sure this is having deja vu. This came up today on the server, didn't it? Somebody said, why do you always use C++ or something? I said, well, it's not my favourite language, but I don't think it's not my least favourite language. It's a language that I can code in reasonably fluidly, and it just gets the job done. I think you get to a certain age where you don't want to just start accumulating more languages that you know under your belt. It becomes utterly pointless, particularly in the professional world. If you go into an interview and say, well, I know 23 different programming languages, whoever's interviewing you is going to look at you and go, no, you don't. You know one of them, maybe all right. The rest of them you don't know at all. It's a dangerous game to start, go down that route of claiming you know all of these hundreds of, especially all these esoteric languages as well that nobody ever knows. Esoteric, like Rust. Yeah. Using C++ as a scripting language. We could do that. We could just have everything as DLLs. We've got to compile all the time. Final Fantasy script. Yeah, Lewis Sol 2. Almost fast as pure C++. No, it's not. So again, these are, it's just people shouting all of these things and not actually sort of having a sensible reason to be saying these things. Like I've looked at Sol. I mean, I'm not going to use Sol because on the channel and things we do everything from scratch. That's fine. But people say, oh, it's like, oh, Lua's, yeah, we can make it as fast as pure C++. What is pure C++? What does that mean, right? It's not going to be. If not used in the hot loops, yeah, you don't want to use it in hot loops at all. The only languages that matter are different assembly languages: C, C++, C#, Java, JavaScript, Python, maybe PHP. I do like C++. I think honestly, and this is going to be very controversial. I think there's absolutely no reason for C to carry on being a thing. If you want to code C, you can still use C++, so that's fine. If you for C#, I think C# is going to have to dominate over Java. I think as soon as it gets like really mainstream Linux acceptance, I think C# will become sort of the de facto enterprise application language. It's almost there as is, because Java is a complete mess. It's so sad. I like Java. The clue's in the name, but it's awful now. I cannot recommend it to anybody that wants to use it. JavaScript, I've never been into the web side of things, so I can't really quantify the JavaScript and PHP thing. And Python, I just don't like. I don't like Python at all. I think the syntax is awful. I think the development environments are awful. I think the libraries are awful. I think everything about Python is dreadful. It's a really controversial code zone we're having tonight. So we can already see the dislikes racking up on the JavaDex9 Extra channel. Yeah, see, that's what I think changed. See, it has built-in stuff, and that's fine, right? Computers are well fast enough now to get your standard Office applications up and running smoothly. They have been for years. So it's going to be fine for enterprise things. Yeah, exactly. So my chat is, I always read through them a bit delayed. For some reason, people love to brag about speed when it is so rarely something that is. But it isn't, right? Most people will never need to concern themselves with programming speed at all. Yeah, I'm a 15-year-old Java vet, and they've really ruined it. Yeah, they have. It's such a shame. I always the joke I always made when people mention Java on the service. I always felt clean programming Java. I don't know what it is. It's like the way that it makes you code things. You have to kind of be syntactically complete. Now I know it's not perfect by any means, but there was something nice about it. But yeah, as soon as they sort of moved away from conventional GUI technologies, I mean, Java was good for that sort of stuff, cross-platform GUI. As soon as they started moving into all of these different frameworks, and the frameworks changed every 18 months, you could never stabilize it. It's no good for somebody like me in my industry, where my software will last for 10, 15 years maybe. And it could be that in 12 years, somebody says, oh, can you add this feature to it? If I can't get the original tool set back to make the software, I've just got to rewrite the whole thing. So it's it's something I can't bet on. I can't actually recommend people start projects in Java. C++ has the same problem with GUI at the moment. This always comes up, this. C++ GUIs are a mess too. And there's this new technology, the WinUI3. If you've ever had a look at the source code for WinUI3, you think some of the source code I'm writing is bad, where you've got namespaces like 3 deep like this. You're in for an absolute shock when you see what the recommended approach is going forward. It's disgusting. And again, a complete mess. In fact, it's so bad it's actually off-putting. You're getting to the point now where C++ looks so atrocious. It's so riddled with templates and so riddled with standard library things that the code is no longer actually readable. And I think that's a tipping point. And I think the C++ guys, they have to be very careful about going there. What did you major in? Talk more about your disdain for Python. My disdain for Python came about when when hang on, this is quite a few. Just staying for Python. It's not. I used Python ages and ages and ages ago as part of my PhD, and it just leaked everywhere. I had to use it in an embedded manner, and it was a complete pain. There was nothing I enjoyed about the experience of it at all. And then after I'd spent a couple of weeks building it was actually to construct neural networks, going back to what we were talking about before, and I'd spent a few weeks building this interface, and then I was just so thoroughly underwhelmed by how it all performed, and I just thought, you know what, I've wasted my time. I've actually wasted my time trying to do it like this. I could have just done it all in C++ in the first place and be done with it. What did I major in? My first degree was in computer systems engineering. My PhD was in neuromorphic engineering. The language you use depends on the problem. Exactly, it's absolutely right. Right, so you choose the right tools to solve the problem you're trying to solve. We're getting quite distracted from space thing here. Come discuss on our Discord server. Yeah. Opinion on Rust. I think it's fairly well known, my opinion on Rust. I've not used it enough to have a proper opinion on it, but I don't like the compiler telling me how I should code. I think it takes all of the expression out of code. For me, coding is a hobby. It's like writing. It's like drawing something, or playing a piece of music, or whatever. It's a way for me to express my thoughts and the way I want things done on the screen. And as soon as a language comes along that says, no, you can't do that. You can't do it like that. You've got to do it like this. And suddenly my code just looks like everybody else's code who's trying to solve the same problem. It's not for me. Not interested in that. Can't recognize that C++ because last time I learned C++ was 10 years ago. Yeah, that's right. I mean, C++ has changed so much in 10 years. It really has. It looks like a completely different language. And it's not that the language has changed. It's now everything is standard library. Everything is meant to be as object-oriented as it can possibly be. And it doesn't have to be. And that's an important thing I think people need to remember. It doesn't have to be. Have you looked into Serenity OS? Super cool project you could contribute. I've enough going on in my life. I have a full-time job. I've got a 7-week-old baby, and I've got a community with hundreds of thousands of subscribers building a pixel game engine. I've enough. Here's the thing. If Lua is compiled before runtime instead of interpreted, then it will run as fast as another compiled language as long as the compiler isn't crap and the algorithm isn't totally busted. Interpreted languages are compiled on the fly, so it's these all sound like this is what we would call clutching at straws, right? Here's the thing. Yeah, the add instruction in Lua can be just as fast as the add instruction in C++. If. Pascal, yeah, Pascal was actually a good language. I enjoyed Pascal. I've got all sorts of people getting excited about the different languages and things. Golang, I've never used. Do you know what? I don't even really know where to start with Golang. I don't know anything about it other than we've had a few members on the server that used Golang quite a bit, and they seem to enjoy it. But I've no experience of it at all. Thank you, Prototypeo. I like that name, Prototypeo. The unsafe block in Rust is kind of, well, yeah, exactly. Right? So the fact that the language kind of needs it tells you that something's it's not quite right. I'll tell you what though, with Rust, and before we finish today, because we have kind of run out of time, and I've said this a few times on the Discord server. Rust developers, Rust guys, the guys who are actually making Rust, why the hell are you not absolutely bombarding the embedded systems market? Forget the desktop stuff. Forget all of this nonsense. Go and straight after the hardware market, because that's where tools and configuration utilities like that offered in Rust, and the ability to manage things properly and securely and in a known way and have consistency across code bases, that's an industry that absolutely is crying out for it. And Rust, that's where you could really make a dent. I know you're starting to think about it, but just why are you not absolutely ploughing all of your resources into that industry? I have no idea. And with that, we've done, as usual, we've done absolutely bugger all, haven't we, regarding space thing today. So sorry about that. There looks like there's a very active debate going on now about different languages. Do get onto the Discord server and carry it on. There's thousands of people on the Discord server all happy to argue about which language is best, and they'll do so in a fairly civil way, except for a couple of people. Yes, derailment of the week was successful. That was it. Okay, right. Thanks, guys, and take care, and I'll see you later. I know at the end of the streams I always say, "Oh well, I'll be back on Friday or Sunday." I'm not making any guarantees, just at the moment. The Javid X10 is certainly consuming a lot more time than I ever thought it would, and I've spoken to a few parents that I know online, and I've completely underestimated how difficult it is to be a parent. So if you are a parent, you have my utmost respect. With that, I will see you later. Take care, everybody.